Hey, good to see you, and welcome to Radio News Channel. So today our topic is Webb Telescope discovers 6 rogue worlds, shedding light on star formation. A groundbreaking survey using the James Webb Space Telescope has uncovered 6 potential rogue worlds, planet-like objects that drift through space without orbiting any star. This discovery, made in the star-forming region NGC 1333, located about 1,000 light-years away in the Perseus constellation, provides fresh insights into the early stages of star and planet formation. These newly identified rogue worlds range from 5 to 10 times the mass of Jupiter, making them some of the smallest free-floating objects ever detected. Among them is the lightest object ever found to possess a dusty disk, a characteristic that suggests it may have formed similarly to a star. Dusty disks typically form around young stars and are essential for the birth of planets. Lead author Adam Langeveld from Johns Hopkins University explains, "We are probing the very limits of the star-forming process. Discovering objects that resemble a young Jupiter raises questions about whether they could have become stars under different conditions." The findings come from the Webb Telescope's most in-depth survey of the NGC 1333 star cluster. A newly released image by the European Space Agency captures the nebula glowing amid interstellar dust and clouds. The survey's results, soon to be published in the Astronomical Journal, challenge existing models of how stars, planets, and intermediate objects form. Johns Hopkins Provost Ray Jayawardhana, a senior author of the study, noted that these discoveries blur the lines between star and planet formation. The smallest free-floating objects that form like stars overlap in mass with giant exoplanets circling nearby stars, he said. Despite Webb's advanced capabilities, the telescope did not find any objects with a mass lighter than 5 Jupiters in the observed cluster. This observation suggests that any lighter objects likely form in a different way, similar to how planets develop in a star's disk, rather than from the direct collapse of gas and dust clouds. One of the most intriguing findings is a newly discovered brown dwarf with a planetary mass companion, which is rare and could redefine our understanding of binary system formation. It's likely that such a pair formed the way binary star systems do, from a cloud fragmenting as it contracted, Jayawardhana added. These rogue objects may form from collapsing molecular clouds that lack the mass required for nuclear fusion, the process that powers stars. Alternatively, they could emerge from the gas and dust in disks around stars and later get ejected from their star systems due to gravitational interactions with other bodies. The research team is also investigating the potential for these rogue worlds to host miniature planetary systems. Those tiny objects with masses comparable to giant planets may themselves be able to form their own planets, said co-author Alex Scholz, an astrophysicist at the University of St. Andrews. Looking ahead, the team has been granted additional time on the Webb telescope to study more of these faint objects. They plan to examine their atmospheres in detail and compare them to more massive brown dwarfs and gas giant planets. This research aims to further unravel the mysteries of celestial object formation and explore whether some rogue worlds could have miniature systems like Jupiter's or Saturn's moons. With Webb's unparalleled sensitivity to infrared light, these discoveries highlight the diverse and complex processes behind the birth of stars, planets, and everything in between. The Polaris Dawn mission is another step forward in commercial space exploration, paving the way for more advanced space missions and possibly even life beyond Earth. So that's all for today. Thanks for watching. Don't forget to like and subscribe to my channel.